Welcome to the virtual classroom. So this is our Jupyter Notebook working environment. So now let us start our demonstration for handwritten recognition based program, machine learning model. So here our first step is to import the required library function. I have divided our required library function to be imported for four different aspects. The first aspect is to import the library function useful for visualization process. For example, input matplotlib and pylab represent the library function useful to display our images or dataset in terms of images or 2D graph or something like that. And second step is to import our dataset, and third one is to split our dataset. So this particular requirement of library functions are available in sklearn. So this sklearn.dataset import load digit and sklearn.model underscore selection import train underscore test underscore split are the library function useful to import the dataset and split our dataset. And last requirement is to build our support vector machine model that can be useful, that can be done with the help of importing this particular library function, which is also available in sklearn. So now let us run this cell. Okay, so the second cell represents importing our inbuilt dataset. The main advantage of using a sklearn library is that it holds some of the useful inbuilt datasets and good datasets. So here we have called this library function sklearn.dataset input load underscore digits. So this function is useful to import our most famous MNIST dataset. All those datasets are handwritten images. So just by calling this one single line, we are now capable of importing our dataset. So this digits is the variable which holds our dataset right now. But one thing is that we don't know how many number of images are available in this particular variable. Now let us explore the dataset first. Now let us make use of this visualization process in order to display any random images. So this particular cell, so now let me run this code, and now uh, let us display this sample images. So here instead of 0, let me give any random index. Let me call any random index. So if we run this code, it will display, it looks like 3 or 5, maybe 5. So now let me change the random index of our dataset. Sorry, let me change the random index of our dataset and run this cell. So it is a 9. So this particular image stored in the index number 14 is a image or representing the digit 9. See to the size of the image, it has 8 number of rows and 8 number of columns. Okay, so this is an visualized image. So now let us explore the input pixels of this image. So what is the index we have called here? Index we have called here to display the image was 14. Now let us see the pixels of that particular image. So this 9, digit number 9 has this input pixel. See, even in this case we can see 8 number of rows and 8 number of columns. So totally 8 into 8, there are 64 pixels used to store any of the handwritten digits. So now if I want to display a group of 50 number of images, not only images, the images along with its associated target functions can be displayed. So that can be uh, demonstrated with this particular cell. So here if we see the images along with its associated label is being displayed here. Now let us explore and check how many images are available in our dataset. See, length of digits.images will check how many images are there, and that number of images are stored in the variable named n underscore samples, and it is being printed for our reference. So there are totally 1797 images in our small dataset. Now next function is to split our dataset into input features separately and output target label separately. So these are the input features and these are the output target labels. So as we have seen earlier, so there are 64 number of input features, 8 rows and 8 columns. 64 number of input features are there. So now let us convert our size or shape of the input into 8 into 8, which is equal to 64. So that can be done. So we are segregating our data set with input image features separately and converting it into a new variable named x. And we are segregating our target separately and converting it into a variable named y. So now our data set with input features with 64 input features is available in x and output label separately available in the variable y. So now, so let me run this cell. Now let us split our data set randomly by making use of this particular function. So this function will split our data set. So before we have seen there are 1797 images in our data set. So this data set is divided into training set and testing set. Let me run this code for now. So there are 1347 images in our training set and 450 number of images in our testing set. This 64 represents input feature size 8 into 8. So now is the time to build our model. So we are thinking to build a support vector machine classifier. So already the scikit-learn library function is imported earlier. So with that aspect, we are going to build our model. So let me call this new model as model underscore linear. Why? Because I'm thinking to design our SVM model with a kernel named linear. So these three are hyperparameters. Not only these three, there are many hyperparameters for a machine learning model. For this algorithm, I have kernel type, degree is equal to 3 and gamma is equal to scale. So this one single line will build my support vector machine model. So this SVC represents. Support vector machine is useful to do the classification task as well as regression task. So here I am aiming to do the classification task, right? So I am giving svm.svc. So this one particular line is useful to do the process of training. So I am taking into account this x underscore train and y underscore train in order to train my model. And here I am doing the testing process. I am taking x underscore test alone. I am going to show the input features of test dataset and do the prediction process. So the predicted output labels are stored in the variable y underscore pred. See, recall our original dataset is having the labels in the variable named y underscore test. So these are the predicted dataset. So while doing the prediction, what we are going to do? So we are going to check the performance of our new model. What is the name of our model? Model underscore linear dot score. So once we run this, so let me run this code first before checking our performance. So once we run this code, what happens? We are testing the performance of our linear model with respect to one single parameter score named as accuracy. So as of now, it is showing 98% of accuracy. So if I intend to even improve the accuracy or performance measure of my parameter, I can do hyperparameter tuning. Recall, in the first time while I was building my model, I have considered kernel function to be a linear function. So now I am deciding to design RBF based kernel for my SVM classifier. What is this RBF? It stands for radial basis function. So what I have done, I have created a new model and calling this new model as model underscore RBF. Just by changing this kernel parameter, the remaining other two parameters are same. So now once I build this model, I am doing the training process, testing process and evaluation process. Now let me code this, run this step. See, there is a slight increment in my accuracy. See, before it was only 98%. Now by using RBF based SVM, so my accuracy has increased to 98.88%. So you can even play with these three parameters and not only limited to these three parameters, you can go ahead and explore the documentation for SVM in a scikit-learn library and include many parameters of importance and give some changes and try to improve the accuracy as well. And now I am not satisfied by evaluating the performance of my model just by using one single parameter named accuracy. If I want to test my model with various other parameters such as precision, recall, and F1 score, along with my accuracy, I can go ahead and input this particular library function named as input classification underscore a report. So these are named as a performance metrics in scikit-learn library. So now I'm going to do the prediction process for my first model underscore linear. So now once I print this classification underscore report, it shows this numerical list. So this particular column represents the digits available from 0 up to 9. So this shows like if while doing my prediction, all the input images carrying named as 0 is 100% calculated as 0 itself or predicted as 0 itself. Coming to the picture of 1, only about 91 percentage of 1 images are predicted as 1. Uh, while taking precision as my performance metric. Well, I consider F1 score as my performance metric. I have this model has considered to give 95% accuracy in order to predict all input images of 1. Right? So these are the details to increase the number of performance metrics.